So move some things around. All right. So welcome to the fourth and final ARM radar listening session. This one is going to be focused on the Eastern North Atlantic, or ENA. And some of the goals we have here with this meeting is, one, I really want to hear from everyone on this call that has scientific interest in the ENA radars. We want to define the scientific priorities for these radars and look at what would be done, not what could be done. So what are the needs right now? Not what you could do in 2-3 years down the road if you had funding. We want to look at what is needed to do the science. Are there any barriers? Like, do we need additional data products, or are there other resources that are necessary? And before we really dive in, I do want to just get a idea of those on the call here and how you've used the data. So we're going to do some poll questions here quick. The first one that Michelle's going to put up is going to ask if you've used any data from these radars at ENA in your research in the past. So if you want to please make a selection. And then as those are coming in, we'll get the results up on the screen once we have them. Okay, so a lot of you are using the KASER data, with some also using the XZapper and the SACR. Okay, that's definitely good to know. For the second question here, I really want to see if you have needs for these radars in your existing research. So just a simple yes, no, to see what the demand is here for these. And we'll wait for those to tally up and see the results. All right, so most of you, which is good to see, definitely a lot more than some of the other sites have needs right now for ENA radar data. So that is great. So let's dive in here. So the ENA radars, they're all second generation, or essentially the newest radars ARM has procured that have been deployed there. We have our X-band scanning ARM precipitation radar, or XZapper. We have our KAW band scanning ARM cloud radar, or KAW SACR, and then our KA band zenith radar, which is just our vertically pointing radar. Again, these are all what we call second generation, because they are newer versions of these radars. Looking at the scanning radars more specifically here, looking at the specifications, they're all dual pole for the XZapper and then the SACR as well. And probably most of note here is the XZapper is that 1/2 degree beam width. And the SACR, when beam matched, is they're both at 0.32 degrees for the beam width. Which is, and I'll just let you look here. I won't go through all the other ones, but those are the two that I think are most important here. These radars are located on the north side of the island, as shown on the Google Earth image on the left. And then a layout is shown on the right here, thanks to the web and communications team. If you ever want to, go to arm.gov, go to the ENA area, and you can take a virtual tour of this site. But again, much like our other ARM sites, there's a lot more instrumentation at this site, from LiDARs, ceilometers, microwave radiometers. We have an array of precipitation instrumentation in the field, from Parsifals to Wayne Bucket, 2D video distrometer, and so on. So there's a lot of instrumentation at this central facility. It's all there in that one location. Now, we've been collecting data at ENA since 2013. The radars were installed in that 2016 timeframe. So we have some data from these instruments. They've been down for a little while now. but we'll talk about that a little bit later, as there are plans for the radar engineering team to actually go out there on a trip in a couple weeks to get these radars up and running again. So the XSAPR, we have data through, from May 2017 to April 2018. This was what was collected during what was called our calibration, grooming, and alignment period. Essentially, that's what it was. We're working through calibrations, adjustments on the system, really just checking the system out. So it's listed under a D1 facility. For those of you that go after our data streams and search and download in data discovery, that's where you'll find that data instead of our normal C1 facility for ENA. Now, this did coincide with some of the ACNA campaign, and the scan types that we have data for, there are sectors, along wind RHIs, crosswind RHIs, and zenith PPIs. The SACR similarly had data collected during this calibration, grooming, and alignment, which is available from June 2016 to 2017. And then regular operations at with the C1 facility from 2017 to 2018. I'll go through the scan types a little bit later here and a little bit more in depth with the latest scan strategy we had operating for this. So just hold tight there. And then the KASER, of course, our workhorse, and the KASER RSCOL product is available from July 2015 to current. So we have some data there. As I mentioned, we are going to be working on getting those radars back up and running. So looking at that SACR scan strategy here, that was essentially last implemented, I believe 2018. I pulled some data from here. So as you can see, we have 6 hours of data here. We have a heartbeat of this scan strategy, essentially every hour and 10 minutes roughly. So it cycles through high resolution vertical point scans, vertical point scan, just our standard. And then it has full volume PPIs, single elevation scan PPI scans. And then also in here is the horizon to horizon or hemispheric RHIs, our crosswind RHIs as well, which do form a large portion of this scan strategy. So this is what we've run. We're definitely going to be talking about this in the discussion section a little bit if there's changes or ways we could improve this. But I wanted to give you a sense of where it was at in the last time it was running. So looking at the data here, just to maybe give you some examples of what the data looks like. The KA SACR is on the left. The W SACR is on the right. This is for May 26th case in 2017. Both looking RHIs through the cloud. You can see some nice comparisons there. Later on in the day, if you look at the PPI or the sector scans, again, KA SACR on the left, W SACR on the right, you can see some notable differences in the returns. So the W SACR does have some diminishing sensitivity the further you go out. Now the XSAPR that we have here as well, this is also 5 minutes later from that case from the SACR here. So you can kind of see that broader view. Now with this, you also do see there's a lot of seed clutter as well in that area, but with having the polarimetric variables here, we can easily look and see what the real echoes are essentially. So this is just looking at some of the data from this of what we can do with these systems and what the views are. Now, I do want to see if Andre can, I see Chandra has his hand up.
Sorry, didn't mean to be disruptive. I was typing that question. Is it one of those X bands you have that's got a fine beam?
Well, yeah, so it's a 0.5 degree beam width.
Yeah, I just wanted to make sure that we're talking about that. Thank you.
Yep. Okay, so I will see if Andre wants to come on here. I see his video, but I don't see. Oh, there's Andre in Yachen.
Something with my laptop, so I move it in Yachen office. So I am here. I can give you a short update. Can you hear me?
Yes, we can hear you.
So we are leaving on 22nd. It's a 2-week trip. So from your presentations, the radars were visited 5 years ago. It's a miracle that the Kaiser is still working without any maintenance since 2017, 2018, that when last time we visited the site. So our plan is to put back the stacker. So both K and W stackers were prepared and were functional on the test bench here at PNNL. I show you some pictures that one of the pelican cases was cracked, and visually it's no damage to the radar, but we will see after we'll install and we'll try to power up the units. So will be a full maintenance for the stacker pedestal, will be we will perform all the maintenance work. The fluid rotary joints will be exchanged, the gearhead will be exchanged, the communication with the computer, with the control computer in the shelter will be transformed to optical communication. So hopefully we can handle all the issues with the sector and we became operational. We will try with the same for part of the 1 hour heartbeat is a little bit too long for the testing. We'll set up some shorter heartbeat for testing the radar, and we are open for discussion for any scan strategy, our base scan strategy, and we will set up or on the island or after remotely the scans with the stacker. X-Zapper, it's not scanning, it's not moving. Brandon will make it to the island 2 days earlier, so first thing he will check on the X-Zapper. We do not have main at this moment. I don't know about main hardware issues, so hopefully with the parts we have on the island for the pedestal, for the radar, we will try to do our best and put back in scanning modes the X-Zapper. For the Kaiser, just the normal maintenance. We'll check the output power, we'll make some power measurements, some alignment, and that is our plan. So for 2 weeks, I think that will be a lot of work, and I can give an update after we evaluated the radars.
Thanks, Andre. Do you expect to be able to make trips out there on a yearly basis, or how do you?
I do not have answer for this, so still the travel is limited.
Mhm.
Yes, so probably technician will visit the site twice a year, or when it's possible. If it's needed, the mentor will go to the site, but everything is pending from approval.
Mhm. Okay, perfect. I guess I'll open it up here for any questions on the actual ENA site, the radar hardware, before we dive into the discussion. So if there's any questions, please raise your hand or ask in the chat. Chandra, yeah.
Oh, it's just a courtesy comment. We have a 0.3 degree beam X band at chill. And that fine resolution, you'll be able to see some unique features that you can see at the what I call as the garden variety 1 degree beam radars. So that's pretty cool. But I haven't been involved, so I haven't had a chance to look at the data. But that's something that I wanted to say, and because we see things, at the end of the day, now I'm speaking to Scott Cole is here. End of the day, because he likes to speak at 30,000 foot level, because all that you see in the atmosphere is observations at multiple scales, and so you have a unique, because we do see things at when you have 3/10 of a degree beam antenna, we can see things at different scales, but one of these days we have to convert that to quality to quantity. Okay, I'll stop there.
Okay. Thanks, Chandra. Any other questions or comments on the hardware or the site? Otherwise, we can get into the discussion here, and really just to start off, like I said before, we want to hear from everyone on this call that has research dependent on Ena radar data. So with that, let's just dive into defining what are the top scientific priorities here, and which radars are important for each of these priorities. Is it using the X-Zapper and looking at 3D distribution and evolution of precipitation, liquid water content retrievals using the KAW band? What else is there that is important that these radars can help advance the science? And Chandra, I don't know if your hand is up here or.
Sorry, I should have taken it down.
Okay.
But can I still say something? I was going to raise my hand. I was going to raise my hand thinking it was down, but one of the things I want to say is, because it's mostly, Rob Wood can correct me if I'm wrong, it's mostly warm rain, and then the DSD processes in vertical. There are a lot of things to be learned if we can also try to get some cross-pole observations, and those also will understand that if we, especially when we have drop oscillations, that's something that was hot when initially polarimetry was introduced, and which was very useful. And I myself did some of the studies in Hawaiian Islands those days. So that's something that could be really unique in this environment, and others can. And I see Scott also there, and we need to.
You mentioned Rob Wood, I believe. I was going to actually pick on him and call him out here as well. So
yeah,
Rob.
quite happy to. I don't know about the oscillating drops issue, but that's an interesting one. I think that's exactly what you've got there is what I would say are really the two of the key priorities. Being able to map out the precipitation, vertical structure, and horizontal. I know the example you showed was for a deeper system, and this is where some of the utility is not as good for the low cloud systems because the sensitivity really drops off fast. For the horizontally scanning KA and W, the shorter wavelength ones, but have a problem there. But I think getting good quantitative precipitation estimates out of the X-Zapper is would to me be a very high priority. The liquid water content retrievals, dual frequency differential attenuation approach just seems to me very promising, but when I talk to people, they say it's pretty difficult to do accurately. So that's one thing. The other thing I think is really useful is the Doppler, right? For the vertically pointing Doppler spectral signatures can be a good way to test large eddy simulations, in particular like process models, because they don't all agree, and this is a good way to sort of really check on them. So the Doppler information can be very useful. I don't know whether I don't know. I didn't prepare anything, so but we can start the discussion or something with that. But or
Yeah, I see Scott Collis, you have your hand raised here.
I see Scott G just wrote in the chat as well, one of the comments I was going to say, which is, as well as the radars, it really is essential we deploy some instruments that are better able to in situ characterize some of those drizzle droplets as well, because our current disdrometers won't cut it. Furthermore, I also put in the chat a question for Andre, and Andre, I fully understand if you don't have those numbers on hand, but I'd love to know what the minimum detectable pre-integration detectable signal is at 10 kilometers from that X-band system, because the Challenger's point, as well as being 0.5 degrees, so giving us amazing spatial resolution, it'll be sensitive to so much more than what we're used to seeing from an X-band system there. So really getting at that, you know, sub minus 10 dBz transition, drizzle transition, which will give us some very, very exciting physics. And by the way, the example that Adam showed, I need to point out, that was taken at 0 degrees. We don't want to just be scanning at 0 degrees. That's why we have such an incredible field there. There was a paper published recently, and I cannot remember the first author for the life of me, but it showed that there's this problem with LES models, and that why they can get the with you know spectral bin microphysics, they can get for an individual grid cell, they can get the microphysics kind of right. What they can't do is reproduce the mesoscale structure of these drizzling cells. And while other people are talking, I'll look up the reference and post it in the chat. And to kind of Rob's point, you know, in terms of a science perspective, and this is from the viewpoint of a translator who reads a lot of stuff, doesn't do much of the science myself. Yeah, documenting that mesoscale structure of those drizzling stratocumulus cells is where this is great. And to my point, I said in the NSA, you know, if you ask me 3 X-bands in Oklahoma or this X-band in ENA, I would say this X-band in ENA, because it's in a unique position where there are no other radars.
That is a good point, Scott. I guess any other thoughts here? I would look to, you know, Scott G, your name came up a couple times here. Do you know, just the spatial precipitation, the liquid water content retrievals, the drizzle analysis, if we were to get different instrumentation out there to go after drizzle at the surface, what else? Or Mark, see your hand up.
Well, actually, I just wanted to sort of echo some of the things that Rob had said, and maybe echo, well, I guess not echo, but give you a little bit of perspective on where I'm at right now on this. And that is that, you know, we have a lot of years of Kaiser data, which we have really combed through very carefully. At least, you know, there are more papers on spectral analysis, but there are a lot of stuff right now that really does a very nice job in terms of characterizing radar echo and basically getting cloud fractions and things like that. My point is that, you know, we've had a number of years of data there, and some of us, me included, I'm really kind of just getting started on the 3D part of this problem. It's like I'm, you know, we're just starting to look at this stuff, and the value of it. You know, I guess what I guess I'm saying is I'm not sure I can really gauge totally what the value is right now. I just know it's really, really important. And there are, you know, I am particularly interested in how the organization of mesoscale boundary layer convective complexes occurs over that region, and it's by necessity a 3D problem. And so I guess I'm very anxious to have the radars back and running, even though we have some data, because I believe really that's where, you know, at least my research, I'm headed in the 3D direction, and we now have some modeling results to compare with those larger scale things. And so I feel pretty good about where the radars are. I'm really anxious to get them back and really support what's going on to get them back and running and continuously collecting data, because I can't tell you how valuable it's been for me to look at several years worth of data from this region. It's really been very illuminating.
So I guess a question for you, Mark, on that comment then is having it up and operational long-term a higher priority than producing, high quality targeted IOP data sets?
That's a really tough question to answer for me, but I mean, I always want to say long-term, but on the other side of the coin, there's a practical point to this. I think things like ACNA, where we had, aircraft data to support that, I think it's really important that we have, these IOP periods where we do bring to bear a lot of different things on the problem. And would there be times of the year when I think we could probably safely, or at least reduce the data from some of the radars? Maybe there are. Maybe we could do that on as far as the KASER goes. But it's all very hard for me to say not to collect long-term data, because I think at the end of the day, from my perspective, is what we're trying to see is not only how this thing works, but how it changes over periods like a decade. Mm-hmm. So for me, spot samples are great, but I personally think there needs to be some element of a longer term data set, even if we don't collect data every day. Maybe there's some way we could do that. So that'd be my perspective on it. I would hate to say not to collect long-term data.
Okay. I'll look at Scott G. You've had your hand up here for a bit.
Yeah, just to make a comment, since my name was mentioned a few times, to kind of go back to a few things. The first one is, and it's something Chandra had mentioned, that these are dual polarization systems, but they're not necessarily taken advantage of for that in that environment, mostly small drop warm rain. However, you do list on the screen, and I think this goes to the science priority or what it may be, there is that the difference between what say you would get from the column in the case of, I'm thinking the SACers, is there an advantage to the dual frequency that you have for retrievals? Is there still much that can be exploited there? Trying to get liquid water path, liquid water content in the presence of drizzle or the presence of precip, that's part of the decadal vision, one of those things that made that list. And so that would, in my mind, only come well in the column by potentially pointing that radar vertically. And I see we have like Ed Luke and other experts in that area who could speak to, is there a substantial value in the dual frequency from that system versus, just the spectra from the KASER in the first place? And then subsequent to that, from a product development side, again, this is always the battle here, is that the radars themselves are either scanning or pointing vertically. And so what is really the priority? Because if I have tended to find, certainly on the product side, if you're mixing and matching and trying to do things the way we did in the past, you don't really satisfy anyone because you're just rotating between things. So I think it really is more of a statement of trying to identify, is the spatial structure captured well with the XSAPer? Do you need the KSACer for that subsequently, or would you point that vertically? Is there a value of having another vertically pointing K-band and W-band matched to try to do dual frequency retrievals?
Okay. Mike, I see your hand raised, but I would be curious if anyone has any thoughts on that. If there's value in just pointing the KAW vertical.
So I was going to kind of talk about that a little bit, but I'm going to
Go ahead.
To disagree with Scott on that. Or maybe not disagree, but say yes, I agree that vertically pointing the dual wavelength would be useful. But I think one of the outstanding questions for our measurements at ENA with the vertically pointing KASER is how representative is that measurement of the kind of larger area, and what are the gradients around the coastal boundary we have there? And I think the only way we're going to get at that is by doing some of this scanning with the cloud radar systems, long wind and crosswind, kind of like we did at ACNA, but we need to resolve those questions. We're going to need a much longer data set than that. So you asked Mark the question before about, do we need long-term or dedicated IOPs? I think we could do something intermediate and do it seasonally. So presumably the summer time periods are when we have the most boundary layer clouds around there. If we focused on that time period and could get the, take those statistics for, 4 months a year or something like that, that would go a long way towards resolving some of those questions.
And Mike, that's actually a perfect segue, because one of the poll questions I had later on was what sort of season is most important. So Michelle, would you be able to pull that up here? You know the summer. I'm curious if everyone else on here is in agreement with that as well, if that's something we could. So let's poll the group here and see what comes back. So please check a box. And maybe while we're getting those results, Rob, do you have?
Yeah, I think when we were thinking of ENA as a site, there was certainly a focus on the summertime. I think is when you get the most sort of stratocumulus type of boundary layers, but the rest of the season there's a lot of interesting phenomena. Cold air outbreaks, for example, are really more of a winter phenomenon. A lot of the precipitating clouds, so boundary layer clouds, I guess, do occur in quite significant numbers all year round. So there's more in the summer, but still a lot in the winter. So yeah, I put all seasons equal here. And
okay, and that we have 50-50 here. So equal votes for just summer being more important, or all seasons. So
I think I just want to add one thing. There's a part of my answer was a little bit about, well, if you've got an asset there, why would it not be working all year round, right? But if you feel that you could get better quality data out of subsetting it to smaller windows and making sure that, hands on deck there for looking at those, then, I could change my answer, but that wouldn't be a science driven, that would be a more logistics driven.
So one of the other aspects of this too is the data processing. Starting with the cacti campaign, the data mentor team really worked hard to get calibrated B1 level products out. Going forward, if ARM says that a radar is operational, we really want to be providing those calibrated B1 level products for the radars as well, which does play into this. Like if we could just focus on those products for the summer period versus the whole year, that's going to free up resources. So finding out, even if we do operate the SACR or the SACR and SAPR for longer periods, maybe where do we focus on the data aspect? And Jim, I see your hand up here too.
Yeah, I mean, to this question of why wouldn't we just operate them all the time, and is it just a logistics question? I mean, I think particularly for the SACRs, this may be less true for the SAPRs, but particularly for the SACRs, and I think for all the scanning radars, we really are learning how much is required to get one of these systems into to top form. It takes some months for one radar to get it to that state. And then it will persist in that state for a period of time, sometimes, often on the order of a half a year, or maybe a year, sometimes less, but not indefinitely. So there is this cycle. We don't have a team to dedicate to each of these radars. So we're trying to figure out how do we best allocate our resources around to these systems. So to some extent, if we can find a phasing that gets us the measurements that we most need by each site, that is a solution which could help us optimize the data that we provide. There's going to have to be some downtime. Now, if the science really does demand equal priority at all the seasons, that's important to know. But it really is helpful to understand if there's greater value at certain times, because it can help us as we try to develop this phasing. I mean, it is a logistics issue, but we're trying to couple that with the science issue. What we're really trying to get at these sessions is to understand what are the science drivers, and we can prioritize those so we understand, well, we'd like to do all of these things, but maybe we do most of them. At the same time, we're going to be looking at the operational side of the house. What does it take to support all of these systems? And the goal is to come up with a better match between the practicalities and logistics side to the science needs. And I'm sorry if I repeated some of you said earlier, Adam. I came in a little bit late, but I just wanted to spend a few moments on the soapbox.
Yeah, no, that's great, Jim. So, Mark.
Just a quick comment. Full disclosure, I voted for summer. I wanted to vote for summer and winter as priorities, not necessarily that I don't want all year. I'd love to have all year, but but I think having 2 seasons to contrast is really important. And I think we've seen that all through the ARM program, at all sites, all places, you need contrast. And so I would say summertime and wintertime would be, for me, the 2 top priorities if we had to just name priorities. I think there should be 2 seasons in there, not just 1.
It looks like there are some thumbs up there as well from others.
Yeah, I totally agree that one of the unique features of this site is getting seasonal variations in marine boundary layer cloud scenario. It's just very rare to get that, right? So
yeah,
support. But I could go with Mark. I could say, if we have to narrow it down, which it makes sense, I think we do, right? Then yeah, go with, and then probably keep those seasons, right? If you're going to keep doing it, like let's say a 3 month in the summer, 3 months in the winter, just keep doing those, and maybe.
Okay. All right. So there's been a lot of good discussion here. I did have some other questions queued up here to maybe further the discussion. Looking at the specific radars like the XSAPR, how can we maximize the benefit of that system, the half-degree, longer range? Is it valuable to just have that in consistent low-level elevation PPI sector scans, or are the RHIs valuable as well?
That's a
Or
quick
maybe
comment from me. This is from a product generation point of view. If you want good QPE, consistency is key. So nice regular heartbeat, preferably starting every 10 minutes, something like that. The angular scans we had were great because that really took into account where the mountains were. Definitely a series of sector scans. Then again, I'll leave that to Andre, what the optimization is there in terms of wear and tear on the system as well, because I imagine that large antenna can, if you stop and start it all the time, it's probably going to wear things down. Looking, this isn't really necessarily pertaining to ENA, and you leave it to the experts there, but those RHI scans give such wonderful vertical structure, being able to go there and also visit the midpoint. And that's the other thing, is constantly visiting the vertical is always a really nice thing with any dual pole system there, even though, again, I know that this could be unique just simply because the number of spherical drops there. But if in terms of product development, making these products more available to a much wider community, gridding them and things like that, nice nested sector scans is just a joy to work with.
Okay, thanks, Scott. Any other thoughts on that, on how we could optimize the...
Usually the sector scans are the scans which are using more the pedestal, so you have to accelerate the pedestal, and for the huge system for hundreds of pounds, so not that is the best for the
and again, the trade-off there, Andre, could be just to do it as PPIs and we just block out, or because I know we have some, if I recall correctly, we're also not allowed to transmit at some, I might be thinking of another system, but I don't think we're allowed to transmit at some of the azimuths either. The airport is blank. Thanks, Scott. That I remember. Boy, that was testing the old memory there. But yeah, we just do PPIs then and just keep it going. I fully appreciate that.
So we don't want the radars to sit there. So for the fall and spring to not use them, but we can set up some scans which are not using as much the mechanics. It's thinking about the suckers which have fluid rotary joints. So that fluid rotary joints at high speed and all the times direction change, they are used more. So we will run the radars for the whole year, but if it's not interested data, maybe we can set up scans which are not consuming as much the pedestals. So that is the idea. We will not turn off the radars for 3 months or 4 months, but we can set up a different way for when it's interested data for summer and winter, and just do some light scans during the spring and fall.
Yeah, Andre, I think that's a good idea. I'd like to hear from others here. You know, if we can go to these lower impact scans during, you know, maybe spring and fall, still get you some data, but it saves our hardware a little bit. What are the thoughts there? So I'm not hearing any disagreement, Rob.
No, yeah, I think that's fine to do that. I think Scott mentioned the repeatability of, you know, and I have a different reason for like wanting to get kind of relatively frequent PPIs at a given level. It's just because you want to track the clouds in the features over the between times to look at how it evolves, right? So you need enough repeat time that it's not too far apart, that you only get one look at a feature.
Yep. So I guess, you know, Scott noted that you do get the nice vertical structure with the RHIs. Is that important here, or is it better to have just higher temporal resolution?
And Rob, one thing that the area of research in the NexRad community is this idea of the sales scan. So what you could do, for instance, is you could do your nested PPIs, but then go back every now and then and revisit one of the elevations while the scan is going on. That way you get kind of the best of both worlds. You can get the 3D structure, but a much more consistent repeated revisit to say a 0.5 degree scan as well. So maybe, you know, if you're doing like 10 tilts, you know, two of them or 3 of them, go back and revisit that 0.5 degree. And then in the final scan, you do your HSRHI to come back, for instance.
Yeah, that sounds good. Mark, Scott, thoughts?
Just a quick comment, which is that how can we maximize the benefit of the XAPR? I think this discussion is fine. I would be fine with that scan strategy. But my response to that question is ask me in a year, because that's I feel like I still don't have enough time, and we're just really getting into this, for me anyway. I mean, others probably have delved a lot more deeply into this, but for me personally, a year from now, I think I'll be in a better question, or better, I guess, better mode, better place to answer that question. Right now, it's still something that I'm just toying around with and playing around with.
Okay. Yeah, and that makes sense. Scott G.
Yeah, and that's also kind of to parrot what Mark had said. I mean, one of the challenges, or one of the things that I think we did have ACNA, and so there were plenty of circumstances in the summer where, and that summer in particular, had a lot of very thin clouds that XAPR will not see. So, you know, you do have to understand what the sensitivity of each of those radars are, and I think that had always been one of the challenges, and those who are in ACNA can correct me, that was at least both with the SACers and the SAPR, is that their sensitivity was just not what others were seeing from then, say, the Kaiser. And so what you do and how you scan may very well be dependent on if that XApper is there for drizzle mapping and spatial context, then that would dictate what you're going to be doing with that system more so than trying to do RHIs if you really don't think you're going to get those very thin stratocumulus clouds. And I think we even saw with the KA Sacker that we struggled with capturing some of those properties. So again, it kind of speaks to, does that drive then not doing PPIs or other things and then trying to do very detailed or RHIs or something with better sampling that might be able to reconstruct those fields more appropriately.
Mm-hmm. Okay.
Sadly, what Scott said is absolutely correct. We did a 4-year study, and of all the Julys in our 4-year study, the ACNA June-July period was the one with the most thin stratus. It was weird.
Okay. I guess shifting gears to the Sacker then here, I mean, Jennifer had put together and led a radar measurement strategy, and I'll talk about that on the next slide here a little bit, but some of the things is looking at, reconfiguration or redeployment of the Sacker system. So, I know these liquid water content retrievals, that's something that we need the Sacker for, right? Are there other scientific priorities that we need this Sacker for that we can't address with the Kaiser and the XApper? Are there any thoughts on that?
Still don't think I personally feel like I could answer that question, having not really. I mean, we're just getting into it, so I'm going to abstain on that one, actually.
Christine, yes.
Can you hear me?
Yes.
I think that's sort of a link to your first one, the 3D distribution and evolution of a precipitation. And I think what is missing there is actually the collocated cloud water and precipitation together. I think that right now we are at the stage that if we really wanted to understand the microphysical processes and how they interact with dynamics, we do need to have both together and in the 3D cloud, in the 3D sense. And I think especially if we go to the LASSO or like a high resolution modeling, etc., how that 3D cloud structure introduce the inhomogeneity of surface radiation actually is going to become more important. And we will need the Sacker in order to reconstruct the 3D cloud field and the precipitation, and then so can have a more sort of a coherent and complete picture about the cloud field.
Okay.
Does that make sense? Yeah.
Yeah. Would you say it would be beneficial then to try and, sync up the XApper and Sacker scans as much as possible when it comes to getting that 3D volume? If trying to sync up the PPIs at the same time, or if we do have RHIs on both of them, sync those up?
I was thinking about that, but I don't know the answer because I haven't done that, synchronized scan. But I think that nowadays the retrieval method doesn't really require everything look at the same volume. That's my thinking. And that's what I had the comment about dual frequency, because we are able to retrieve a 3D cloud field if we can, the radar reflectivity can be constrained by some short-wave radiation measurements. So that would be sort of an alternative. But of course, the dual frequency is great.
Okay, Jennifer.
Yeah, I just wanted to push on this question about the sensitivity of the Sackers a little bit more. And based on what Christine was saying, can we study these processes, the cloud microphysical processes, with the Sacker in its current state and sensitivity levels? And I don't know if we can answer that today, but that's one of the issues and one of the reasons that we discontinued the Sacker operations at SGP, because it did not have the sensitivity. But can we reconfigure the system so that we can get the sensitivity that we need? So that's one question I'm grappling with.
Thanks,
I don't know if we can answer it, but
Christine.
think about.
Yeah, because my PhD student, former PhD student did calculate that sensitivity, and we are able to get the shallow cumulus cloud even for the old scanning, but that one was the cap MBL though. So, but I think it should work, especially the SACR right now has a much better sensitivity, is it?
Okay, that's good.
Okay.
My understanding is not just sensitivity, correct me if I'm right, there's also the attenuation problem, right?
I believe so.
Do you find that an issue, Christine? I mean,
This is the cases we are looking at. I didn't see that though, but maybe I looked way too thin, not attenuated enough, but we can take a look. But may I just say that, you know, I think ASR scientists or science, sort of like a world leading is also because of all the fancy retrieval stuff. Not, I mean, many groups and in this call has all contributed to that sort of a leading role there. So I think we are really at the very good place to tease out all the detail about cloud property. And one thing I think the scanning radar we haven't really pushed has two things here. One is the LiDAR scanning is not quite really matching our precipitation or cloud radar. And I think that's a sort of a missed opportunity because with the LiDAR has some sort of a synchronized scanning, we actually can push the separation between cloud and drizzle. The other one, sorry, I forgot. I will come back. I can't remember now.
Yeah, so right now our Doppler LiDAR is really just going between fixed point and these VAD PPIs to get the wind profiles, right? So you'd see maybe scanning it more high resolution in a similar manner as the radars. Okay. All right. So, you know, looking at the retrievals for the SACR, are there additional retrievals, you know, that could help make the data more useful? You know, we talked about the liquid water content. I guess for either of these, is there any other retrievals that would be beneficial? You know, that's something that ARM could look at from the data product side.
This is Rob. We talked about quantitative precipitation estimates, right? A best estimate for precipitation. Christine and a number of other people talked about that. So that would be one, because I don't believe that's yet available. It's not easy, but and Pavlos, you know, and others have outlined how you might want to leverage the CASER to, you know, do generate kind of ZR relationship, or like establish some ZR relationship for one vertically pointing radar and then apply it to this XSAPR. Things like that kind of might involve multiple instruments. Can make it complicated, but might be more accurate, right?
Yeah. Okay. Any other thoughts there? Otherwise, you know, we can, Jennifer, this is, as I already mentioned, part of the measurement review was to really look at the SACR system. You know, some of the things that did come up in this is that if it would, you know, would it provide more value at another ARM site versus ENA? You know, would this have a bigger impact on scientific priorities if this type of system was deployed with, say, one of the AMFs? And if there's no, and I'll put the rest of these out as well, just as some questions. Would it provide value, you know, if it was offset from the main facility? You know, that was one of the options as well, to offset from the main site as well, if it would provide value, or as we've been discussing, you know, additions or changes to the scan strategy. So are there thoughts on any of that, Mark?
Just I don't know about the offset. That's something new, and I really want to think about that a little bit before I would answer. But I guess I would lobby for not yet moving the SACR, because I still think we're still not far enough along research-wise. This is just my own thoughts. I mean, others may have different thoughts, but I feel like we're just not far along yet. I don't think we've gotten everything we can get from the SACR at ENA, and we still are, I think, still in early stages of what might be done there. And I don't think we quite have enough data yet to make a conclusion, for at least for me to draw a conclusion on it.
Okay. Any other thoughts? Or Jennifer, is there, Scott G?
Yeah, I mean, I have to run off, but I guess when I've been approached on this, my way of answering that is this particular SACR is a very high quality dual polarization SACR for which that dual pole capability may be not taken advantage of at this site. That might not necessarily mean not having a scanning cloud radar at that site. I think it would be differentiating, well, do you really need this particular system, or is there just a scanning K-band? It kind of goes back to your questions, is the our W bands have been somewhat problematic. They're not as sensitive or not as useful, I think, at least in my opinion, from what I've seen, as we would have hoped them to be. And if we are not taking advantage of the dual frequency from those systems, the question is would we be better served with, they say, just a separate scanning cloud radar that was non-dual pole? I mean, it maybe is this system as a fully dual polarization system more valuable in another environment, not necessarily removing that capability, just a different version of that radar.
Yeah, that's a good point. Are there any thoughts on that? If Mark, if we could, replace it with just a routine KA band scanning radar, is there?
I could see arguments on both sides of this. The only thing I would point out, and there may be others on the call that can address this more than I can, is back in the back of my mind is the paper written by Lermite a long time ago, in which there is the mean minimum in there, and we have, and it's in a spectral processing realm. Whether we would use that at ENA in drizzle enough to justify having a W band alone if we got to that, and I don't think many people have really gotten to that, that would be a scientific justification for having it. However, I could see that, that if we weren't going that direction, or if we didn't really think we could do accurate enough liquid water content profile retrievals, that maybe there wouldn't be a need for it. So I guess I could see arguments on both sides of this.
Okay. Scott, is your hand back up?
Yeah, I guess my follow-up would be that I do agree that the dual frequency has value for precipitation retrievals, but we've never been able to realize that. And part of it is because spectral processing, and I know we had Ed Luke on here, and he knows this better than anyone, it's very difficult. And the question is, are you really adding that much value to go through all of that effort to then get, in that case, where you're getting those signatures best, are you need to be legitimately into precipitation size drops. You're talking about, more than 1.5 millimeter size drops. So this is not drizzle anymore at that point. This is now rain. And so I kind of go like, well, if I thought that we could achieve the decadal vision, liquid water content in the presence of drizzle type retrievals, and we had a path forward for that, then I would certainly not be advocating for removing the W and KA and X vertically pointing, that kind of capability. I guess I would be more questioning, do we need the scanning capability? Is the scanning W band, for example, valuable in the presence of attenuation? Versus just exclusively having, say, a scanning KA or a scanning X band that's a high quality X band. That's maybe more of what I'm arguing, as in, do we really need a scanning W band?
Okay.
Unknown for me, and good point. Yeah. I don't know.
Okay. Any other thoughts in that area? otherwise, just some basic questions here too is, out of all these systems, if we have to prioritize them on what we keep operational, what is the highest priority? And I should have made a poll question out of this, but is the highest priority the XSAPR followed by the KA and the W, or is there a different prioritization? Or if there's no, Christine.
Can I ask you the WSACR?
Mm-hmm.
If we don't have it at ENA, where do you plan to have it?
I don't think we have that information at the moment.
Okay.
So,
Is that, I don't know if the Chandra is still there. Is that possible to make it not scan then? Because we don't have a W-band vertically pointing at the ENA. I don't know. Chandra, are you there? Anyway, because Chandra's has a very cool technique to separate the cloud spectrum and the drizzle spectra. And then what they found is the W-band is much better and it's more sensitive to those the information that requires. So he sort of a suggestion at some point that it would be nice to have a W-band vertically pointing. And I just wonder if that can be used in that way. Just a comment.
Okay. And reconfiguring this is always something we can look at as well. But with both these antennas on the same pedestal, there might be some issues with the balance if we were to just remove one. So we would have to look at potentially bringing in a whole new case after I believe we still have our marine W-band arm cloud radar MWACR as well, but that we would have to discuss. So Jim.
Yeah, I mean, a reconfiguration like that is not something we'd be in position to do in the next year, but it would be very valuable to know if that would be make scientific sense, because I think in the long run, it would be much easier to maintain such a configuration, probably get better sensitivity out of such a configuration. So if it scientifically made sense, then it would make sense to target that in a longer term plan. So it would be useful information if we thought we could get, for example, better value from a single wavelength scanning system and multi-wavelength profiling. It's not what we have today, but it doesn't mean we couldn't have that in a few years.
Yep. Okay, thanks, Jim. Are there any more thoughts on that? Otherwise, the last question I had down here to talk about, and then I'll maybe see if we covered everything Jennifer needs as well to inform the measurement strategy. But just in general, are there any products or open source codes that ARM should provide to make these data more useful? We talked about the QPE and whatnot. Is there anything else that we could be providing, whether data products or open source code in PyArt or elsewhere, that could make this more beneficial to our users or easier to use? Are there any thoughts? But if there aren't any thoughts there, I guess I'd maybe ask Jennifer if there are any remaining questions you have.
No, I think I heard what I need to hear. Let me repeat what I think I heard. That we need a little more time and a little more data to make any specific decisions about the SACRs, but that we should maybe do some evaluations of the sensitivity and attenuation of the systems and really try to understand that before we make any decisions about how to reconfigure them, or if not, just leave as is. So
yeah,
if that's not right, let me know.
No, that definitely sounds good. Yeah, just noting what Scott's been in all these listening sessions as well. I really appreciate the conversation here. This did kind of flow nicely. If there's anyone that has any final thoughts or final comments, speak up now. But if not, I know we're over the hour. I promised we wouldn't go the whole time here. So for just to follow on to this, I'll be writing up a summary. I will post some of the key takeaways on discourse.arm.gov. We have some radar topics, and we'll make one for ENA radars as well, that we can kind of further discuss and provide some feedback on the key takeaways here, just to make sure what we heard and what we take away is the same as what you have. And then finally, there will be a survey, I believe, at the end of this breakout that Michelle will be putting in, and she's been great. A big thank you to Michelle and the communications team for helping out with this as well. So if there's no other comments or questions, we can let you go here. All right. Thanks, everyone. I really appreciate your time.
Thank you, Adam.
Great,
Thanks,
thank
Adam.
you.